right, in example 2, find the value of x, then tell whether the side lengths form a Pythagorean triple. So first we need to find the value of x. Is x a leg or a hypotenuse? It is a leg. It is a leg. It's all good. What is the other leg of this right triangle? 15. So we're going to plug in x squared plus 15 squared equals, what is the hypotenuse then? 25. You don't need a calculator because these are simple. 15 squared is 225. 25 squared is 625. What would we do from here?
You subtract it.
Subtract 225. So x squared equals 400. My bad. 400. Take the square root, and what does x equal? 20. So x equals 20. Have we answered the entire question? No. It says, then tell whether the side lengths form a Pythagorean triple. Can someone raise their hand and tell me what they think a Pythagorean triple is? Jerron. All the sides are whole numbers, and they make a squared plus b squared equals c squared. So we have that happening here. So yes, all of them are whole numbers. Ta-da. In our next picture, it's not technically a word problem. Why am I going to say that?
Because
there's a picture of the triangle.
Literally gave you a picture. So students today were like, oh my gosh, a word problem. Literally has a picture. It already told you where x was. It told you where all the measurements were. If you look at this picture, is this whole outer triangle a right triangle?
No.
No, it is not.
No.
It is, however, an equilateral. No, it's not.
What?
It's an isosceles. Sorry, wrong one. Well, he said equilateral. Why is this an isosceles then, Cole? Chris.
Because those two legs are equal.
The two legs are equal. X and X. Alright, so let's use our very intelligent, hopefully, very intelligent 10th grade minds. How do these two triangles, the one I've outlined and the one right next to it, how do they compare? What do you think?
That they're equal.
They're equal. They're congruent. They're the same measure. So if we find X in our triangle, it's going to be the same X in the other triangle. So I see we have X. Is this a leg or a hypotenuse? Hypotenuse. So then we have 8.5 is a leg. How do I find the measurement of the other leg?
Look at the right, and it says 15.1.
I agree. So this shows the height from the ground to the top of the wire. So it's going to be the same here as well. So it's going to be 15.1. So we'll plug in the two legs. So we'll have 8.5 squared plus, what is it, 15.1? 15.1 squared equals x squared. 8.5 squared is at 72.25. And 15.1 squared, 228 or 27? 0.0, I'm going to do 0.01. All right, we add those together. What do we get when we add them together? 300.26. Take the square root, and x equals. So whenever it comes to this, you need to look at what everything else is rounded to in the picture. How many decimal places are there in the picture? 1, so we can answer with 1. So it's going to be 0.3. That'll be it.
Yeah, 0.3.
0.3, yeah. That eraser is in the perfect spot. All right, we got 2 more. Tell whether each triangle is a right triangle. So which one of these, so we're going to use what formula? A squared plus b squared equals c squared. Which one of these will be the hypotenuse?
4 times the square root. What?
12.
Definitely 12.
It's okay. People make mistakes, Andrew. Good grief. Let people make mistakes. Here
It doesn't mess.
we go. It is going to be 12. It is going to be the longest side. So we're going to plug in the 2 legs. So we're going to plug in 8 squared. When we plug in 4 square root of 5 squared, what did I tell you? You need to make sure you do. Parentheses. And then it equals 12 squared. It also does not equal 20. It does not equal 20. So please hold your... Come on. 8 squared is 64. When we take 4 square root of 5 squared, all of it is being squared. So you need to make sure you distribute. I appreciate you for trying, but you didn't distribute the 2 to the 4. All of it's being squared. So 4 squared is 16. So 4 squared is 16. The square root of 5 squared is 5. Because remember, a square and a square root cancel each other out. So 16 times 5 is... It's 80. It's not that big, but... And it equals 12 squared, which is 144. Let's add 64 and 80 make 144, which equals 144. So is this a right triangle? Yes, it is. Last one. Verify that segments with lengths of 14 meters, 15 meters, and 11 meters form a triangle. Is the triangle acute, right, or obtuse? So we're going to be verifying first. To verify, we take the 2 smaller sides and make sure they're bigger than the largest side. So what are my 2 smaller sides? 14 and 11, which make 25. Is 25 greater than 15?
No. Yes.
Yes, it is. So we're good. So because of this, we can figure out what kind of triangle we have. It is not. So we're going to plug in the longest side first, because remember it's c squared, and then a squared plus b squared. So what is the longest side here? 15. 15 squared. All right, and then so the other 2 legs will be 14 squared and 11 squared. 15 squared is 225. 14 squared is
196.
And 11 squared is 121. So our last step, we're going to compare 225 to whatever 196 and 121 make. 317. Which make my hypotenuse squared smaller than my legs added together and squared. So what kind of triangle is this? Acute. Such a cute one.